All right, so we are going to be moving into the next section here. And let's take a look at these problems as we go through. So I'm not going to go in order as you see them. I will be going the left side and then the right side. So here we're talking about the domain issue. And what I told my students is, there's a couple of issues where you have to worry about. If I wanted you to graph this function here, and you didn't know how to graph it, you would need to make a t-chart and pick some numbers that you could plug in for in for x, do the math, and then get their y. So sometimes when you pick a number for x, like -10 or 10, and you put them into your equation, you're going to find out that it doesn't work. You're going to get an error message, for instance, when you use your calculator, because you can't take the square root of all numbers. You can only take the square root of 0 and higher. So those become our domain issues. So the idea is, what numbers, if I had to make a t-chart, would I pick? So the issue here is we have a square root, and inside the square root, we can only take the square root of 0 or higher, positive numbers. So I told my students, what you do is you take what's inside the radical, and to show that the math that we're going to do is going to be 0 or higher, we write greater than or equal to 0. And now you're just going to solve for x. So to get x by itself, I add 9. And then I divide by 4. And that gives me x. The values I pick for x in my t-chart need to be greater than or equal to 9/4. You could write it as its decimal if you wanted, 2.25. So what we did then is, to get this idea, because we're not going to be writing our domain like that, is we put it on a number line. And, x's can be very small or very big, so that's where we put our infinities. And then we put this number here, this 2.25. I'll use the decimal version. And I can pick any number that's 2.25, so I make a circle and I close it, and then it can be bigger than 2.25, so this side. So when you look at the picture, we're starting at 2.25, we're going to the right to infinity, and so that's how we're going to write our domain. We're going to put a bracket first to show that we want to include 2.25, and then we're going to put a comma with infinities, and this is how we'll be writing our domain issues. So let's take a look at 7. So on 7, I run into an issue because, again, if I wanted to graph this, I've got a denominator, and I can't divide by 0 in the denominator. So what I can do is I can take the denominator, and I told my students we don't want it to be 0, so we're going to say it can't equal 0, and I'm just going to solve for x. So there's two ways. One is you could factor. This is a difference of squares to solve for x. And you would never pick 4 or -4. The other way to do it is get x by itself and add the 16 over, and then take the square root of 16, and you'll just have to remember that you wouldn't want 4 and -4. So again, from there, I'm not going to write my domain like that. I'm going to put it with infinities and commas and stuff. So from -infinity to infinity, -4 and 4 would fall in here. And I don't want those. So this time I would put open circles, but I will take everything to the left of -4, in between -4 and 4, and more than 4. So we start with our first section and we write it as -infinity to -4, parentheses on both because I don't want to include -4, and then I can go from -4 to 4 again with parentheses because I'm not including those values, and then from 4 to infinity. So what's in blue is the actual official correct way to write the domain. So when I go to problem number 9, what I notice is I don't have x in a denominator. That's one situation I have to worry about. And I don't have x in an even radical. So if I were to make a t-chart for this, I can pick whatever I want. And so the way we write whatever we want to pick is we just do -infinity to infinity. There are no domain issues here. All right, let's go to number 6 and take care of the right side now. So on number 6, when I do the problem, I notice I have a variable in the denominator, and that means there's the chance that that denominator could be 0. So I never want this denominator of x minus 10 to be 0. So I'm going to solve for x, and x just can't be 10. And again, now if you like to do that number line, you can. Some of you don't do this. So negative infinity to infinity. Here's my 10. And I want everything but 10. So I'm going to put an open circle. So I'll take this side of 10 and this side of 10. So when I write this, because I have two sections here, here's one section, here's another section. This first section goes from negative infinity to 10. And I don't want 10, so I put parentheses. But then my other section goes from 10 to infinity. So I'll write the other one as 10 to infinity. So what's in green and red, the infinities with the 10, is your answer. So number 8. So when I look at number 8, it's a little different because I have a 1/4 power, and hopefully you remember that a 1/4 power is the same as a 4th root. So when I look at this, I really have a problem here because I'll be taking the 4th root of potentially negative numbers, and you can't take the even root of negative numbers. So in the end, what's in here, what's inside that radical, has to be greater than or equal to 0. This will ensure that what I'm taking the 4th root of is 0 or higher. So I'm just going to solve for x by subtracting 5, and we get this. So all of my numbers that I would pick for my t-chart would be -5 or higher. So again, I'm going to do the number line for some of you. And negative infinity, infinity, here is -5. And it's okay to have -5. That's what this underlined part here says. And then I want bigger than 5, so I would go this way. So I only have one section to describe. It starts at -5 and goes to infinity. And since it's closed, I can include -5 and parentheses for infinity. And then the last one, I have another problem because there is a variable in the denominator, so that denominator could become 0. So again, take what's in the denominator. Here it's just x, and you don't want it to be 0. And there's your domain. Don't pick 0, but we'll write it with our infinities. So here's 0. I don't want 0, so when we put a circle, we leave it open, but I'll take to the left of it and to the right of it. So I'm going to write my answer in two parts. The first one will be negative infinity to 0. And I don't want 0, so use parentheses. And then I'll do for the second part right here. And I'll go from 0 to infinity. And there is your domain for number 10. All right, now we're entering the function operations. And this is probably where it gets a little bit tougher. We're going to be putting these two functions together. And we're going to be subtracting them, adding them, multiplying, and dividing them, and also looking at their domain issues. So before we get into part A, I just want to remind you that a 1/2 power that you guys see here is like a square root. So it might be easier if you look at f of x as 2 and x to the 1/2 as the square root of x, and the -4x to the 1/2 as -4 with the square root of x, because those square roots are going to cause domain issues. You can't take the square root of negative numbers. So first we're just going to start with subtracting. So I'm going to start with f of x. I'm going to put it in parentheses. And you can write it like this. Or you could write it this other way that I showed you. But it's in the second way that I showed you that you're going to realize that you're going to have a domain issue. And it won't matter if there is a subtraction sign connecting these, or an addition sign, or a multiplication sign. We will have the same domain issue for A, B, and C. And so they are both the same thing inside the square root. So I just have to realize that inside that square root, which is an x, I have to make sure that it's a positive number. So it can be 0 or higher that I can take the square root of. And again, we will not write our domain like this. If you make the number line and you're going from negative infinity to infinity and you put 0 in there, 0 is okay, so I put a closed circle, and then I want greater than that. So when I look at my domain, it will start with 0 and end with infinity. And so, whoops, that should be a bracket. 0 to infinity. And that will be the case, again, it doesn't matter if this is subtraction or if I take it and I make it addition, like on B, it will still be the domain issue. So I'm going to go ahead and over here and put the same thing. Or if I take what's there and make it a times sign, I'm still having that same domain issue. So for A, B, and C, I'm going to have this domain issue of 0 to infinity. Now it's going to be a little bit different on D because of the fraction, and we'll get to that in just a second. So let's finish up with A. I'm going to go back and put the original symbol in there, which was a minus sign. And adding and subtracting, A and B, are going to be very similar. Adding and subtracting has really picky rules. So what I'm going to do first is go through, I'm just going to add the opposite on this one. And when you add and subtract, you're just adding and subtracting your like terms. So for instance, just changing the problem completely different. 2x plus 4x is 6x. And I can add those because I have like terms. But if it was 2x squared plus 4x, I wouldn't be able to add those because they don't have like terms. So when we do this one, we're just describing how many of these square roots of x that we have. And since I've added the opposite, we have 6 of these square roots of x. So when you go to B and you write it, this time it's going to be f of x. And you can write it like this time if you want. Doesn't matter if you write it like this or at the square roots. I'm describing how many of these x to the 1/2 that I have. So if I have 2 here and -4 here, that will give me a total of -2 of these x to the 1/2. And then you have your domain issue. So when we go to C and we take a look at the multiplication, again, I'm going to leave it in its original form for this problem. Good idea to always put these in parentheses. But this is going back to the first part of chapter 5, and this is where I told my students, this is where you make the houses when it's all multiplying. So I would put 2 and -4 in a house, and then x to the 1/2 with another x to the 1/2. And then I would just look at each house and simplify them. So in the first house, I get -8. And then remember, here you just add the exponents, and 1/2 and 1/2 is just a first power. So when we're done, this is C. All right, let's take a look at D. It's going to have its own separate unique situation, the domain issue. For the domain issue, I do want to leave it as the square root. So f of x will be on top, and g of x will be on the bottom. And what's going to happen is we still have that even radical that we're going to have to worry about, but this one is also in a denominator. So when you take what's inside that radical, because of the denominator, it has to be just greater than 0 and not equaling 0. So now when you do your number line and you have your infinities and your 0, we're going to leave it as an open circle and then to the right. So when I write that 0 and infinity, this time it's going to be parentheses and a bracket. Now, as far as simplifying goes, you could do this as the houses, but you know, anything over itself, this is just what cancels out. And 2 over -4 just becomes -1/2 when it's simplified. So that's the final answer for D. So I'm just going to back up here and just show you as if it was written in the other one. Again, you could do the houses, you know, separate the houses. And here we're supposed to subtract the exponents. A half take away half is 0, and anything to a 0 power is 1. That's why in our answer here we don't even have an a variable, because anything to a 0 power is 1. So, but otherwise, anything divided by itself cancels out. Okay? All right, let's take a look at E. So on E, you know, there's a couple of different ways you could do this. So probably the easiest way to progress through E is to actually put 16 into f of x and put 16 into g of x. And I'm going to write them as their square roots. So f of x was this, minus, and then here's the -4. I'm going to quickly add the opposite. And now I'm just going to put the 16 in there. And the square root of 16 is 2, and then 2 times that 2 is 4. And here, I'm sorry, not square root. The square root of 16 is 4, and 4 times 2 is 8. And then here the square root of 16 is 4, and 4 times 4 is 16, and so when you add them up, you get 24.